All right, welcome back to United Astronomy Clubs of New Jersey, a series of winter talks. So before we get into it, I want to thank everyone for joining us here online on YouTube and Twitch. Do hit those like, follow, subscribe buttons that are completely free to do so. It does help us get word out to other people who may not have seen our channel before. And if you're just tuning in, welcome. Uh, in addition, you can also check us out on our website, uacnj.org. It's where you can find a list of all our upcoming talks, as well as information on our member clubs, because we are a club made up of other astronomy clubs, and also information on various telescopes and science that is happening at the observatory. You can also check us out on our social media pages, our Facebook, our Instagram, our Discord server. Uh, all great places to get in touch with us, ask questions, and share your astronomy experience. Uh, Again, big thank you for everyone who is like, subscribe, and the people who have given subs or donations. We are a nonprofit, so everything that you guys have done has gone to either helping pay our bills, uh, helping maintenance around the observatory, or even just upgrading little things for your viewing pleasure at home. So I do want to thank you for doing all of that, and putting a shout out to our Patreon page where you can sign up to help us out. But you're not here to listen to me rattle on, at least not this weekend. That was last weekend. You're here for our monthly What's Up in the February Sky. Lonny Buinis has been giving the What's Up series since the start of UACNJ in the Cretaceous period. He received degrees from Stevens Institute of Technology in physics and computer science, then made space art and taught himself 3D animation and video editing. Lonny is the only member of the International Space Artists to specialize in virtual reality worlds. His current projects include expanding his interactive space history ebook, which he'll shamelessly plug later, and with the help of his uh, this, of course, is with the help of his narrator, Dan Bunis, and his practice of putting his pants on two legs at a time. So, with that, here's Lonny.
Thank you very much, Kim. I want to thank all of the volunteers at UACNJ who make this series possible. Not just my talks, but every Saturday from April through October when we do this live. And they are a hardworking bunch, Kim, Chris, Jeff, and many others. And please do visit the observatory. Kim will tell you more about that later. We're here to see what's up in February, and we're looking at a screen capture from a piece of free software that you can get that I'll talk about later. And it shows the sky for the middle of the month at 8 o'clock. If you note on the lower right, the military time 20 minus 12 equals 8 p.m. And we're looking due south at Orion. Asteroid goes through space, comes to the Earth's atmosphere, streaks and creates a bright flash of light as a meteor, and then lands as a meteorite. This is what you get sometimes. This was a metallic meteorite.
1 second, Lonnie. I think chat lost sound for a minute. So just check. Oh, people are now saying it is back. I wanted to just make sure people could actually hear the presentation.
Yeah, thank you. Thanks, Kim. Yeah, in case anyone out there missed that, this is an actual meteorite fall of a meteoroid from space that flashed through the Earth's atmosphere as a meteor. Lots of terminology here. On January 18th, it was metallic, made of partially of iron, and it smashed a car windshield. Very interesting story. That's the link right down there. If you just look up meteorite January 18, you'll probably. Also in the news, an asteroid with the memorable name 2024 YR4. Why are it called this? I don't know. It's not very memorable, but it has a 1% chance, according to some, or maybe even higher, up to 6% chance of striking the Earth somewhere along this red track, which, as we thankfully can see, is nowhere near New Jersey. But it could cause a lot of damage since this thing is 40 to 100 meters across. That's almost the size of a football field, pretty big, about the size of the asteroid that blew up over Siberia over here in 1908. Killed 3 people, knocked down several others, and 80 million trees were blown down like matchsticks. That one blew up in the atmosphere. If this thing hits the ground, it would wipe out a city. So we're going to be looking at this very carefully to see if we can refine the orbit and get a better idea of where this thing should strike if it does. Now, again, even a 6% chance is less than half and half, 50, but that's enough to be concerned. We got a bit of history. In 1961, on this day, the first anthropoid was launched into space. Not a human being, but in our general family, a chimpanzee, Ham. And a bit of history, personal history. My father was born this day in 1920. I recently polished 86 years of tarnish off of a gigantic bronze medal that he won in a competition when he was 18 years old. He was a very gifted violinist. And that is who I'm named for, short Lonny from Lodging. If you go to starwalk.space, you can find different ways that the events that we're going to talk about for February are listed. That was an awkward sentence. Here's one way, a visual way, but it mixes things that are happening between the moon, planets, what planets are doing, a meteor shower, very minor, that we can't see. The Alpha Centaurids are coming from the constellation the Centaur, which is never visible from New Jersey, so I'm going to ignore it. Instead, I'm going to group the events by general category. So moon phases, one of the most important would be the new moon, when we can have a nice, clear, dark night sky. We'll talk about that soon. A nice lining up, not an alignment as you hear in the news. This is an opportunity to see 7 planets at once in the early evening sky toward the end of this month. And that's 7, well, actually 8 planets right? Which one's missing? Saturn, Mercury. This is going from the west, that's the right, to the left. I'll show you how this works in stellarium. So first you would see Saturn and Mercury close to the moon. And then if you have a telescope, Neptune. Venus, you can't miss. It's super bright. Looks like a drone or an airplane. And then Uranus, again, you need a telescope or binoculars, unless you have supervision and a really dark sky. And then Jupiter and Mars dominate the night sky. And look down at your feet, and you'll see the eighth planet. Then we have a comet that's visible, but you need an 8-inch or larger telescope. And do we have meteor showers this month? Nope. Let's start with the moon. Each month, I'd like to tell you the poetic name for the full moon. These are derived from Native American names, some of them, or names used by the Boy Scouts for decades. This one is the snow moon. Most amount of snow usually falls in February, during February in the Northern Hemisphere. But that's not the only name for the February moon, which you can get more information about at moongiant.com. I do not work, disclaimer, I do not work for any of the websites that you will see in my presentation, but you're welcome to make note of them. Scribble it down, take a picture, whatever you have to do. Do some research, check it out. This is a fun website that teaches you a lot about the moon. And it shows us the different phases of the moon. You can click arrows to go back and forth by dates. I'm showing you the full moon when they have a little bit of news about it. They even tell you the age of the moon, 14.88 days from new. But I mentioned that there are other Native American names for the full moon. And so some of the, I like the long ones. Makes branches fall in pieces moon, the Abenaki tribe of Maine. Or when trees crack because of the cold, when trees crack because of cold moon, the Lakota. Have you ever heard this? Have you ever heard trees groan in the wind? Right, but in the very cold weather, the expansion and contraction of the wood can make cracking noises. Sleet moon, goose moon, animals, or hunger moon. These are all names of the moon that you can find at the Farmer's Almanac. And so I put their website down below. Every month, the Farmer's Almanac tells you about the names of the full moon, including all the Native American names, not just the snow moon. So I mentioned the phases of the moon before. Absolute worst time to see anything is a full moon. You can see some bright stars and planets, but that's about it. Right? Why? Because the light of the full moon interferes. If you want to see faint objects like nebulae, plural of nebula, which is the Latin for a cloud, a gas cloud in space that makes stars and planets. A good time to do that is the end of this month, which would be the last day, unless it's a leap year. New moon, February 28th. So nebulae, gas clouds, star clusters, which are groups, clusters of stars, either open, spread out, or tight in a globe. So astronomers came up with the brilliant name globular cluster. And if you want to see details on the moon, a nice raking angle of sunlight coming across the moon, first and last quarter is a nice time to do that. At night, that would be the first quarter. As the sun is setting, it'll be in the south. Or as the sun is rising in the morning, if you like to get up early, or if you have to get up early for work, that would be February 20th. You'll see the moon sliced in half, bright, half dark. The other side we don't see is also half dark and half bright. So there's never really a fully, well, there is a dark side of the moon, but we see it. It's not the other side of the moon, since the moon always faces us in one direction due to synchronous rotation. Look it up. So if we want to see how the moon does all this, what we can do is use a computer program called Stellarium that is free. Open source means that programmers can contribute to it. You programmers out there can contribute code to this project. And it's a bit like a star chart, like the kind that we sell at UACNJ. Wink, wink, nudge, nudge, right? Inexpensive, made of paper. In a computer program, you can do a little bit more than just move the sky around. You can zoom in and see how big some of these winter constellations really look in the sky, like Orion the Hunter. A little hard to recognize without the lines. We can turn them off and on, and even the names. But you will see these four bright stars making his knees and arm, and Betelgeuse. Look up Betelgeuse. Literal translation is the armpit of the giant. The armpit of the giant. There's his crown. There is a club that he's holding and a skin of an animal up here. See it better with the lines? These are the kinds of lines that are drawn on most modern star charts. Sky and Telescope magazine, Astronomy magazine follow this convention based on the Greek the mythologies, the constellations. Would you believe this one's supposed to be a unicorn? Looks just like a unicorn, right? Right? How about now? No? There are things you can do in a computer program you can't do on a piece of paper. So if you want to see how the moon moves, let's zoom out so that we can see east and west. And the time that we're looking at this right now, right there, 2015, 8, 15, and 16, 17 seconds, 18 seconds at night, our current time. If you do that and you have a clear horizon, the boundary between sky and Earth in the west, you'll see the crescent moon near the planets Neptune and Venus. Of course, Neptune is invisible without a telescope, but Venus is super bright. If you were to have looked at the sky a little bit earlier at 18 minus 12 equals, anyone? 18 minus 12? 6:15 p.m., as the sky is getting dark just after sunset, Saturn and Venus and Neptune are all close. Even the planet Mercury, a little bit earlier, whoa, it's lost in the glare of the sun. It's going to be easier to do that at the end of the month. I'm going to go back to now, though. I can make a line with the planets through the signs of the zodiac, the fishes, the bull, Taurus, with the planet Jupiter, the planet Mars. You can see the moon moving along this imaginary line through the signs of the zodiac, fish, bull, twins, lion. I can make the line less than imaginary. It's called the ecliptic. Don't expect to see this in the real sky. This is the orbit of the Earth around the sun drawn out into space. And why does everything seem to follow that? The sun, the moon, the planets all seem to follow this. The major planets, not the dwarf planets like Pluto at an angle. That's because the major planets of the solar system follow a fairly flat plane, like a dinner dish. The solar system is fairly flat except for comets, some asteroids, and the planet Mercury and the planet Pluto, minor planet Pluto, and a lot of other minor planets. So if we were to speed through time, not only February 1st, 2nd, 3rd, 4th, see the moon? The moon is going through its phases. I've exaggerated the size of the moon 3 times because when we look at the sky compressed down into a small size like this, it would be hard to see the phase. When you look at the real sky, the Seven Sisters looks like a little dipper. And the moon will be there February 6th, right near Jupiter and the Pleiades, the Seven Sisters. On the 7th, looking at the sky the same time, 8:18, look at the difference in one day. Oops, that's 1 hour. The 6th of February, the 7th of February. Why is the moon shooting through the sky like that? Well, the moon is revolving around the Earth in 29.53 days by the phases, 27 1/3 days by the stars. right? There's a difference because the moon and the Earth are moving around the sun, and the moon has to catch up to the same place in the sky. So it takes a couple extra days. All right, so if we keep looking at the moon now in gibbous phase on the 7th, 8th, getting towards full, be right near the planet Mars on the night of the 9th, pass through the stars of Gemini, the twins, Cancer, the crab the next night, Leo, the lion, and finally the moon. The full moon will be rising as the sun sets. Right, so the moon goes through phases, and it rides high above the ecliptic in the winter. Let's go backwards, 12, 11, 10, 9, 8. Look at that. Why is it not on the ecliptic? Looks like it's crossing the ecliptic there on the 1st, tonight. Well, the moon doesn't go around the Earth perfectly lined up with our equator. It's tilted by about 5 degrees, which explains why we don't have an eclipse of the sun every month, right? The moon generally misses it. So that's the phases of the moon in animation through a computer program. Other things to see, the 7 planets that I talked about before, I talked about them a little bit again just a moment ago. We're going to have a little more time to just learn some of the constellations of the night sky. Don't forget the end of the month, February 28th. Good time to try to see the planet Mercury. It's very hard to do that because it's so close to the sun. The first planet from the sun, Mercury. The second planet from the sun, Venus, is further away, still visible as a bright light in the evening sky. You can't miss it, and many people have mistaken it as one of the drones that we've seen over New Jersey recently. We're going to look for a comet near Cassiopeia. Have you heard of that constellation? That's a circumpolar constellation, circum, around the pole, the North Pole, from New Jersey, which is a mid-northern latitude state. There's that planetary alignment that I talked about, drawn out a little more fancifully. You're not going to see the planets looking that big. But Saturn and Mercury will be very close to one another. Neptune, will you see Neptune with the naked eye? No. Venus, super bright, not red, not orange. That's the way it looks in radar, if you could look through the clouds. Super bright and white, brightest of all planets. Uranus, you won't see with the naked eye. You will see bright whitish Jupiter and reddish Mars. And I left some time here to look for Cassiopeia in the north. So a good way to get oriented to the sky is to start in the north. And for those of you who are not beginners, please bear with us. I do this every month. I like to get us started with the 5 constellations that circle the North Pole, the North Celestial Pole, just so that we can get oriented. The Earth has an axis running through the North and South poles. It spins on that axis, and the North Pole points right there to a blue X. So go out tonight, look for the blue X and the letters NCP, North South. Wait a minute. What's that? Satellite. North Celestial Pole. Are you going to see the North Celestial Pole marked out? No. You can notice here that Polaris, the pole star, right, a star in the Little Dipper, right, is not at the North Pole of the Earth. It's close. We're lucky that there's a bright star that marks close to that position. Makes it easy to find true north. To find north, the easiest way to do it is to look for a dipper-shaped group of stars known uncreatively as the Big Dipper. Big Dipper, Little Dipper. We've got some trees in the way at United Astronomy Clubs of New Jersey in Jenny Jump Hope, New Jersey. It kind of blocks things. We do have the ability to do different landscapes in Stellarium. And so there's our observatories. Can you see them? It's a little bit dark. right? We have multiple observatories that you can come and visit starting in April. So to find north, take the pointer stars and the Big Dipper's handle 5 degrees apart, go 25 degrees, 5 times their distance, 1, 2, 3, 4, 5, and you will miss the North Star if you go in a straight line. But it's close, right? This distance or angle is about the size of your fist held at arm's length. And that generally works no matter what your size is. If you keep going, you'll pass the King Cepheus. Looks like a house-shaped group of stars. Above it, a letter M or W, depending on the time of year and where she is, Cassiopeia, the queen, and that's where we're going to find our comet. But it is rather faint. I have a picture of it that I can show you in just a few moments. So once you know where north is, and you find the remaining circumpolar constellation, the dragon is low in the trees and the buildings this time of year. Draco, Big Dipper, Ursa Major, Big Bear, Little Dipper, Ursa Minor, Draco, dragon, Cepheus, house or king, Cassiopeia, queen. Is that a little better? Or is that a little more confusing? Turn yourself around, face south, and look to your right for the stars of spring to be setting. The great square that we talked about last time, Pegasus, the flying horse, the fishes starting to disappear by 8:30 at night, which is the time that we're close to right now. But if you look due south, you won't see the ecliptic, which I'm going to turn off. But you will see the signs of the zodiac that help you find the planets, Jupiter and Mars. We can start with Orion to help us get oriented. Find the belt and the sword, the armpit, the other arm, the knee, Rigel, brilliant bluish white star, reddish orange, kind of reddish or orangey star, Betelgeuse. Your eye can see star temperatures. If we saw the sun at a great distance from us, it would look in color a bit like this star in the twins, Gemini. Pollux, kind of yellowish. Try this for yourself sometime. The best thing to do is take a pair of binoculars, look at Castor, bluish, and Pollux, yellowish, by defocusing your binoculars or telescope a little bit so it smears the light out. Makes it easier to see the colors. That's a famous trick from amateur astronomers who you can meet at UACNJ between April and October. Right now, it's too cold to visit. But if you belong to an astronomy club, your club may be a member of UACNJ. So if I use the belt of Orion to do star hopping, I can hop to the right and come to the face of Taurus the Bull, an old open star cluster called the Hyades. Has a bright reddish star, Aldebaran. This is a giant star, more than 66 light years away. The time it takes light to go, the distance that light goes in 1 year is a light year, right? In 1 year, light goes about 6 trillion miles, 6 followed by 12 zeros. Now you see why we don't use miles. And right near it, the bright planet Jupiter. You don't want to miss looking at Jupiter in a telescope. We have to zoom way in to see, even barely see the disk of Jupiter. And in a small telescope, we can see bright stars. That's some of Jupiter's 4 big moons. And we can see some features on the disk, some bands. These are clouds. Jupiter itself is a gas giant planet made mostly of gases, 11 Earths across in size. Sometimes we can even see the shadow of a moon crossing Jupiter. That's what's happening right now. If you watch Jupiter long enough, it would rotate over time. Back to current time, I've sped time up, and there's the inner moon Io coming out from behind. Let's pause and go back to the current time. These are details you would see in a large telescope or a long exposure picture. Right now, 3 of Jupiter's 4 big moons are visible in a telescope or pair of binoculars. Yep, they're so bright, so close to us, about 500 million miles away, that we can see them even in binoculars if you're careful, if you hold the binoculars steady. Now, if we keep going along Orion's belt in a straight line, we pass the Bull and the Seven Sisters, beautiful open star cluster younger than the Hyades. To our eyes, most of us will see the 6 brightest stars, 1, 2, 3, 4, 5, 6. Some will see 7 or 8, and in binoculars or a telescope, dozens. Recently, it was discovered that this cluster may be moving through a cloud of gas, formerly thought to be the gas these stars were born from, since they're young stars. Only recently born, just a matter of millions of years ago, not billions, not thousands of millions like our sun, which is about 5 billion years old. These stars are going to burn through their fuel in no time. The sun will be around a long time after these stars are gone. But they are a beautiful little cluster, so see if you can find them. All you need is your naked eye. Going the other way, not west, but east, we can follow Orion's belt to come to the dog star in the, yep, you guessed it, the dog, head, body, feet, tail, Canis, dog, major, big, Canis major, the big dog. And of course, there must be a little dog, Canis minor, which being made of 2 stars looks just like a little dog, right? Here, let's test it. See that? Just like a little dog. Our ancestors had some advantages over us. They had drugs, yes, just like we do. They had dark skies, no street lights, no light pollution. They could see the Milky Way easily. They could see Procyon, before Scion, the dog, coming before the dog star. This rises first in the winter. But we, with our binoculars and telescopes, can see that there are other things in the sky to see besides stars and planets. There are nebulas or nebulae. I don't know, take your pick. Some of us like to say ketchup. Some like to say ketchup. Some like to say tomato. Some like to say tomato. Nebulas, nebulae. But one of them is a nebula. This one in Monoceros, the one horn, the unicorn, looks a bit like a rose, so it's called, you guessed it, Rosette, the Rosette Nebula. Beautiful. There are more famous nebulas, easier to find. Even in a pair of binoculars, you'll notice that the center star of Orion's sword is fuzzy, and it is an emission nebula, emitting light on its own, reddish light, the light of hydrogen, the most abundant gas in the universe. Yet, hydrogen and all the other elements we know that glow, that emit photons of light, constitute only 5% of the universe. 27% of it is dark matter. This matter, hydrogen, glows red on its own, but why does it look blue here? Well, we saw the Pleiades had gas that looked blue also. The hot young stars in the center of this nebula shine and reflect light off of the hydrogen gas. And so we have a reflection nebula reflecting light, and it looks bluish. In the very heart of this nebula are 4 hot young stars called the trapezium. Why are they drifting out of our telescope so fast? When you magnify objects very much and you don't have a clock drive, something is moving the sky very slowly. What? Why is the sky moving very slowly? The whole sky is going to be gone in less than 12 hours. The sun comes back because the Earth is rotating, right? So astronomers have telescopes with a drive on it, a drive on their telescopes that compensates for that motion. That's what we just saw. So you've seen, by using the technique of star hopping, you've seen that there are ways to remember how to find constellations just by using one. Above Orion, on the line between Rigel, the bright blue star, if I can pick it, there it is, Rigel, Beta Orionis, Alpha Orionis. These stars are also named by their constellations that they are in. The brightest, the next brightest, Alpha and Beta, from the Greek letters of the Greek alphabet. Make a straight line and go up, and you'll come to the twins, Gemini, Castor, and Pollux, the bright stars. The planet Mars is near there. Let's take a closer look. You need a pretty powerful telescope to see details. Well, not too powerful. Small telescope will show you some details on Mars. A whitish polar cap made of frozen. Oops, I just lost Mars. Let me lock onto it. Frozen carbon dioxide, some frozen water, H2O, some dark markings, lava outcrops, a lot of desert dust. Mars is an inhospitable planet. Amateur astronomers are taking pictures this good of Mars. It's really incredible. It used to be only observatories could do that. But with modern software, stacking up multiple images, using computers to de-rotate the image, planets rotate over time. Yeah, Mars is 24 and a half hours. If we speed up time, we can do that. As astronomers look at Mars in their telescope, they can see new features as the planet rotates. Yep, as the time gets later and later, 23 hours is the same as 11:09 at night. So you see how Mars changed? It rotated during that time. So people have to compensate for that with computer programs. Just some of the wonderful things that we can see in the current night sky. And there are even some minor constellations, like the one below Orion. Looks a bit like, let's see, tail, ears. Do you see Lepus leaping? What's Lepus? Fun you can have in the night sky. Again, as a review, I would say if you go out and orient yourself to north, use the Big Dipper to find the Little Dipper and Polaris, turn yourself around, look to the west to watch the things in the west disappearing, like Saturn and Mercury and Venus and the crescent moon with the new moon and the old moon's arms. The old moon, the crescent, the new moon, the crescent. The old moon, you can see the rest of the moon faintly lit up. What's lighting it up? Are there fires on the dark side of the moon? Streetlights? Earthshine, earthlight, right? Then look over to the south, straight in front of you. About 8 o'clock at night, 8:30 at night, Orion will be right in front of you. You can use it to point right to star clusters in the bull, left to the dog. Follow the winter triangle, Betelgeuse, Procyon, Sirius. You can't miss it. 3 bright winter stars. Some of the brightest stars in our night sky are in the winter. Just happens by coincidence. If you really want to challenge yourself, after you find the winter triangle, find the winter hexagon, 6 bright stars. Can you find them? Let's start with Rigel, 1. Aldebaran, the Eye of the Bull, 2. Capella in the Chariot Rider. Looks just like a chariot rider, no? Pollux in the Twins. Procyon, the little dog star, and back to Sirius. 1, 2, 3, 4, 5, 6. It's going to be a little bit harder because you have Jupiter and Saturn adding a couple of very bright moving stars. One way to tell the difference, stars generally will twinkle because they're only activating about 1 cone of light in your eye. But the planets have disks, And so they send a lot of light. And generally, if they're high in the sky, unless the air is very turbulent, planets don't twinkle, not like the stars. So they move through the sky, they twinkle. A good way to tell them apart from the stars. There is going to be time for us to ask questions, and I can look at detail in things that I might have missed, but I want to do a quick review here. Don't you hate reviews? There'll be a test. A good time to see craters on the moon when the sunlight rakes over the moon, so that half of it's lit up. Right down the middle, the terminator shows shadows and craters and bright lights on the dark side that look like cities. Mountain peaks. That would be the first quarter, February 5th. If you have to get up for work 5 in the morning, check out the last quarter moon late in the month. Check out the full snow moon, the middle, February 12th, and the new moon, the end of the month. Now, what's this GMT? Greenwich Mean Time. That's the time at London. That's our standard time, and we are 5 during daylight savings time. Yeah, or 4 daylight savings time. We're 5 hours earlier. Subtract 5 to find the time in the Eastern time zone that we're in with New York City. 7 planets, don't miss it, February 28th. Did we see what that looked like? No, we didn't. Let's go back. Let's take a look at, wrong program. Here's another free program you can use. I'm going to go forward in time, February 1st, 6th, 12th, 22, 3, 4, 5, 6, 7, 8. February 28th, early. This is 5:40. Mercury will just barely be visible in the trees. Why don't we get rid of the trees? You can't chop them down where you are. I don't know, unless you have a chainsaw and you have authorization. I don't recommend it. What we can do is turn off the ground altogether. Don't show the ground. Oops, let's not do that. Let's use a zero horizon. Saturn, Mercury in Pisces, Venus. This is at 18 minus 12 is anyone? 6 p.m. on the 28th. Uranus, Jupiter in Taurus the Bull. Neptune is very close to these guys. That's an outer planet. And then Jupiter and Mars. So the order, if we go in order in the solar system, Mercury, Venus, we're going to jump all over the sky. Mercury, Venus, Earth, right? Mars is way up there. Jupiter, Saturn, Uranus, Neptune. You're jumping all over the sky. But in order, here, Saturn and Mercury and Neptune, Venus, Uranus, Jupiter, Mars. The major news media are calling this an alignment, which seems to imply that they're all on the same side of the solar system. It's not exactly true. It's more or less from what we see. But if we were to look out in space, we'd see the planets are scattered all over the place, not in a straight line. We can do that called celestia, which lets us fly out into space. Let's see if it'll let me do it. I want to go to the sun. No, I don't want to do that. I want to go over the sun, 90 degrees. And I want to do it at a distance of 100 times the Earth-Sun distance. Why? Because Neptune is 30 times that distance, and I want to see the whole orbit of the planets, the orbits of the planets, like this. So where are the planets? Inner planets orbits are tiny compared to the outer planets. So Mercury, Venus, Earth, Mars, does that look like everything's lined up with the Earth? Mercury is way over there. Venus is to the side. That's not a straight line from the sun to Earth to anything. Let's zoom out. Big orbits. Jupiter is way over there. Saturn's over there. Uranus is over there, Neptune is over there. So it's not a straight line as it was in the 70s when we sent a space probe out to Jupiter, Saturn, Uranus, and Neptune, and they were all pretty much lined up so we could have a grand tour of the outer solar system. And that's what it was called. NASA called it the Grand Tour. We learned a lot about Uranus and Neptune for the first time because robot space probes had never been there before. This is another free computer program that does 3D motion. You can travel to the other planets. Cool. But that's not why we're here tonight. Tonight, we're here to learn about what's up in the sky. The comet, don't forget the comet. Don't forget to look for the Blaze star. The Blaze star, this is very disappointing. Did you hear about this? I've been talking about it all year. T Corona Borealis was supposed to blow up. Well, the dwarf star was supposed to eat more material from the big red giant star that it orbits. And then that material was supposed to fuse on the surface of the star, creating a nuclear blast that we see as a nova. Nova, new, the word for new. And it was supposed to happen between April and September. Did it? Nope, it did not. We did not see T Corona Borealis. But if we wanted to, when would we look? We could look high in the, whoops, sorry to make you dizzy, high in the south. Woo, that was fun. High in the south, when? Late at night, the spring constellations come out. So about 5 in the morning before the sun rises, look in the south for the crown corona. Look next to the star Epsilon and make a right triangle with Epsilon and Delta. And look for the Blaze star. Let me see if I can find it. No, there it is. 10th magnitude means you need like a 3.5 to 4 inch mirror or refractor telescope to see it. But occasionally, every 80 years, it blows up about 16,000 times brighter, becomes second magnitude like a star in Cassiopeia. You'll see it with the naked eye. It will disfigure the crown. Won't look like a crown anymore. There's another darn satellite. Whew. What is that? It's in the Starlink, another one. You're bound to see that if you have a nice dark sky, like we do at United Astronomy Clubs of New Jersey, which is the sponsor of tonight's presentation, which I'm going to close shortly with some hints for getting started in astronomy. You don't have to spend a lot of money. If you don't want to spend money on giant binoculars, which are a very good way to do it, because if you get bored, you can use these for bird watching and other things. There are smaller binoculars, like bird watching binoculars, 7 by 35, for instance, 7 power, 35 millimeters. These are like this one, 20 by 80, 20 power, 80 millimeters is the size of the lens. So the first number is power, second number is size of the lens in millimeters, because nobody on Earth uses anything but the metric system except the US and Great Britain. But I still like it because that's what I grew up with. So 50 millimeters, standard size binoculars, 7 by 50s, it's about 2 inches. These are a lot less expensive than they used to be. We even sell the first scope, Celestron first scope, at Jenny Jump at UACNJ. But you can go online and see the fairly reasonable prices for beginner telescopes. You know, some of you may be photographing this. Does anybody still say photograph? Taking an image. There should be a name for taking an image with your smartphone. Phoning it. Nope, that's no good. How about snapping it? Somebody will invent it, I'm sure. If you have any suggestions, text them to Kim. So Celestron is one brand. There are others. Meade is going out of business. Orion, I believe, might also be, but you might get a nice discount on those. If you want more light so you can see fainter objects, this, of course, is going to cost you more. But the least expensive or the most economical are Dobsonian designs, named after John Dobson, who used to take his big Dobsonian telescope out in the streets of San Francisco. And it was impossible to see anything with all the city lights. But he showed people planets and star clusters. Very nice, to 8-inch, 10-inch, and bigger. The United Astronomy Clubs of New Jersey, repeat after me, UACNIJ. I don't hear anybody. UACNIJ.org, that's our website. We're an umbrella organization of many astronomy clubs, not only New Jersey, also New York, Pennsylvania. Thank you all for being part of that. You can read a magazine, Sky and Telescope and Astronomy, have been in business for decades. Their paying websites are fantastic by subscription, but you can, instead of doing that, you can use their free portions. The free parts of their websites are incredibly stacked with information. And if you forget everything else I've told you, even my name, Lonny, tonight, remember space.com. I think that's pretty easy for me to remember. I'm old now, you know. Space.com. I want to thank the audience for being such a good audience tonight, especially our friend Cheryl, who's watching tonight. Thanks for tuning in, Cheryl. This might be your first time. We're going to be doing this every month, virtually, until we go back to live in April. Space.com also has some of the best stargazing apps. Now, there are iOS, Apple apps as well as Android, but I have an Android, so I was able to find 21 night sky apps. One of them is best for Apple users, Night Sky 11. I like to use Stellarium. These are all free. I've used Skyview before. The best free one seems to be Star Chart, according to this evaluation. Some are good for alternate reality, AR. Some are good for astrophotography. Right? So check it out. See what's good for you. Try them out. All of them, just about all are free. Space.com. And we saw a little bit of Celestia that lets you fly into space and visit other planets and moons. CelestiaProject.space. They have a free, it's all free. You can download it. You can you run it on a mobile device. Stellarium, you can download it. You can run it off their supercomputers on their website. Stellarium. I didn't put it here. Stellarium space. I forget. Check it out. Also, I do want to draw your attention to a nice lunar phase chart that you can print or save and check out and control at moongiant.com. You can remove all of this highlighting and just have a pretty chart of the phases. Once again, toward the end of the month, after the early waning crescent or the new moon sets, you've got a nice clear sky all night long. This moon is in the daytime sky, so it doesn't interfere with viewing. And don't forget the 28th, those 7 planets lining up, not aligned, but all in the evening sky. Here's your review. Ready for your test? Just kidding, no test. You'll find me here at Astronomy in Motion, astronomyinmotion.com. You can play with free 3D objects. You can use your fingers on a mobile device. You can use any pointing stick, mouse, joystick, anything. You can move a century-old picture of Mars to match modern pictures of Mars. You can see what Pluto looks like and zoom in to features on its moon, Charon. Pronounced Charon, not Charon or Charon. You can see how the Kepler space probe would see Jupiter and the Earth from a great distance off, eclipsing our sun, actually transiting. That's how we've seen planets around other stars. And you could buy Mars at your fingertips with all 28 crash and landing sites, narrated by my wife, Jan, on those little red hotspots. But that's in 4K. The HD version is free. That's a sampler, absolutely free, and Mars at your fingertips. That's enough of my shameless promotion. I'm also working on revising my book, Space History Mysteries, which is currently out of publication, but you can expect to see that back, I hope, later on this year. I'm revising it from 5 chapters to 10. I'm currently working on the Star of Bethlehem. There'll be more about that later, but I'd like to thank you for being such a good audience. Kim is going to point out where you can find us everywhere, not just YouTube and uacnj.org. Thank you very much for being a good audience. That's what's up in February.
All right. Thank you so much, Lonnie, for another great talk. So we do have a number of questions that people were putting into chat. So we're going to jump right in here. The first of which, and even though Jan had answered in text later on, we'll give the answer now. Do you play the violin like your ancestor did?
My father was a very gifted violinist who had memorized thousands of tunes, ethnic tunes that other musicians would call him up to for reference. But he taught me. He gave me free music lessons for many years, and I played both B-flat clarinet and a tenor saxophone for about 30 years. I hope to get back to it. My wife will say that'll never happen, but one of these days I'm going to uh, emit some ear-shattering blasts on the instruments in the basement. Maybe our dog will howl.
uh, it honestly, you don't forget. Yeah, the biggest thing with getting back into an instrument is realizing you've forgotten how to read the music. Playing is not so hard. You can get the sound out. Uh, Going, I used to be able to read this gibberish, however.
Yeah, my dad taught me how to read music, so I hope it'll come back. I'm going to start with scales and fingering charts so I can remember. But they do tell you your neurons, even though they haven't been used in a long time, that it comes back. It's amazing. It's like riding a bicycle. Maybe I'll ride the
uh,
bicycle and play at the same time.
mm, I think that
Could
would
be
be less than
dangerous.
advisable,
Yeah,
especially with the tenor sax, because
yeah.
that's a lot of extra weight.
I think I'll take your warning, Kim.
It was hard enough when band teacher in high school decided, let's all pretend we're in a marching band, and then we had to learn how to walk with the instrument and
Ooh,
play.
ooh.
And I'm like, yeah, no, this is not for me.
I
So,
actually was in a marching high school band in the rain, and my clarinet, the silver keys ran on the plastic and turned the clarinet green.
all right. So our next online question: do we think there are more space things that will need distinct names yet, as we discover them, or are there even anything to discover, or are current naming conventions mostly covering all phenomena? So I'm
Oh
imagining they're
no.
talking about how we have nebula, we have galaxies, we have planets.
Right, but we're always discovering new minor planets, asteroids, comets. Comets are named for their discoverers. It could be a human being looking in a telescope. It could be a satellite that catches it automatically in a long exposure. When they discovered Arrokoth, the planetoid beyond Pluto that New Horizons passed, the features on that body were never named before. So they decided on names from mythology, the craters, the features. They do that every time a new body is seen in greater detail, like the asteroid Ceres. When a space probe orbited Ceres, they were able to see more features. So they decided how to name the craters and the impacts and the rays and other features on that body. So yeah, there's always an opportunity for new names. In
I'm
fact, it
wondering if they're
was.
talking about more of the generalized like categories, like, yes, we
Oh,
have planets, nebulas, uh,
yeah, yeah. The all of the deep sky objects,
meteorites.
yeah, so-called deep sky objects, nebulous star clusters, those have all been named or numbered already in many, many catalogs over centuries. So you can't name a nebula. You can buy a star name that's not officially recognized by astronomers, but as long as the company stays in business, they will chart your star that it's named for you, or that is named in your honor. You can do that. There are several star registries that do that.
And I think they don't contact each other, so there's
No.
people buying the same star. So I don't know how advisable that would be either. Um, let's see. Epona, no, the moon is not a drone, even though you're joking.
Yeah,
But you know better.
yeah, Venus and other planets, because they're fairly stationary, they only move with the stars slowly, have been mistaken as airplanes or UFOs, UAPs, that's the new term, unidentified aerial phenomena, or drones or other things.
All right, so our next question. Does Stellarium have a VR headset version? Because then the sky would have labels.
Oh, well, not that I know of, but the mobile version, you can actually it aligns automatically with the sky. So as you move, it identifies everything exactly. And even if you have clouds, doesn't matter. It sees right through the clouds. It knows what's there. It knows if you've been sleeping. It knows if you've been good or bad.
Santa has become uh,
An app.
an app. I was like, uh, oh, Skynet, that's the one. Santa
Ah,
has become Skynet.
mhm.
Um, but yeah, that is actually a good question. If there are specifically apps for stargazing for VR headset, and I actually don't know.
I'll have to
Uh,
research that. Thank you.
like the Oculus or what? No, I
Mhm.
forget any of the other names of them.
Yeah, I wouldn't be surprised.
All right. Let's see. If you guys have any questions, I do suggest you get them in chat because I see we're coming right up on the end of the questions, and I want to give you some time since stream delays a thing. Our next question is, how long before the planets are actually lined up again and not just visually lined up?
Oh, I believe I read the actual year. I don't remember exactly, but I believe it's in the 22nd century sometime. 21 something. Oh, in fact, yes, I'm writing a science fiction story that takes place in 2163 or thereabouts. The outer planets will line up once again. And the reason I picked that is because there's a company in my fiction story now, company that's sending people out there to set up hotels on the moons of those planets so people can visit. And in the future, they have very fast spaceships, so they can get out there and tour.
Yeah, they got to be zooming to get out there.
You'd have to have continuous acceleration spacecraft, and it would still take days and weeks.
And this will sound like an odd question, but ha- if you're traveling out to these outer planets, can you feel how fast you're going? Like it, or is that like you're on a train and it feels like you're stationary, you just happen to be in a moving capsule?
Exactly right. I used to sit on a subway car waiting for it to start in New York City in the subway, and there'd be another car next to us that took off. And I thought we were moving backwards or forwards, but it was really just the other train because that's all I could see out the window. So it all depends on your frame of reference. You would not know you were moving.
Hmm. So as long as there's no windows,
Right.
we're good. All right. Uh, yes, Epona had pointed out we also have a merch site. If you're on Twitch and you do exclamation point socials, it should bring up a link tree with all the links, including to our merch store. You can also find a link on our website at uacnj.org. But thank you for bringing that up. So it looks like our questions have currently dried up for the night. So I want to again thank you, Lonnie, for a great presentation. Thank you guys for everyone who has joined us here. both on Twitch and YouTube. Do hit those free like, subscribe, follow buttons. Um, if you're feeling extra generous, like I said, do feel free to do the paid versions or check out our Patreon. It does help us continue in our efforts for this type of outreach. And with that, I want to wish everyone clear skies and good seeing, and we'll see you next time.